Hello to all of you around the world. I'm Jerry Akubo, the National Technical Director, Interpol NCB, Abuja, Nigeria, and also the drone expert representing the West African sub-region. The widespread of oil spill, throwaway culture, and other marine pollution crime has threatened the foundation of our ecosystem and our lives, turning a breakthrough into a nightmare. The sea has been turned into a graveyard. Oil spill and plastics has been found to choke marine wildlife and has also entered the ocean food chain, exposing marine life to toxic chemicals that can end up in the foods on our plates. A case study of one of the most notable areas of environmental damages caused by oil spills in West Africa is Ogoniland, Nigeria, where oil coats and clings to every rocks and grains of sand in that community. Spilling oil washes into coastal meshes, forests, other wetlands, fibrous plants, and grasses. Today, Ogoniland, Nigeria is unsuitable for human and wildlife habitats. In response to a call to increase international enforcement on marine pollution crime, Interpol carried out a global investigation codenamed 30 Days at Sea, where more than 500 marine pollution crimes were identified, which include illegal discharges of oil and garbages from vessels, shipbreaking, breaches of ship emission regulations, and pollution on rivers and land. I will be talking on usage of technologies to detect marine pollution crime, which we believe can reduce it to the barest minimum. A variety of sensing systems are now available for detecting marine pollution, including automatic identification systems and satellite imagery, which is a vessel identification system that is used for collision avoidance, identification, and location information. Side-looking airborne radar. This is a device that is fitted using synthetic aperture pointing perpendicular to the direction of flight. Electro-optical infrared cameras. This sensor is an optical payload, dual-band camera that combines visible and infrared imaging capabilities in a compact and lightweight package. Infrared ultraviolet line scanner. Also, night vision cameras, sulfur sensors, and vessel tracking softwares. Among these promising technologies, I will focus on usage of modern drones, simply known as unmanned aerial vehicles, to detect marine pollution crime. Up until now, methods of surveying, detecting, and locating leaks in the oil and gas fields have been inefficient and costly to conduct. Workers have risked their lives to climb high-rising stacks, and inspections have caused lengthy activity shutdown. Drones are a cost-effective and safe solution to all of these problems. For example, if you are conducting a shoreline survey, it will typically take a team up to an hour to survey 1 kilometer. The UAV can scan the same area in minutes, and through its unique sensors and availability to reach difficult access areas, drones provide additional information that the physical team will struggle to detect from land. During the 30 days at sea operation, we use drone for detecting and mapping of oil on the water surface. We noted that what a drone can inspect in 5 days could take 8 weeks with human inspection. On oil pipeline inspections, drones can go thousands of miles in minutes and can constantly monitor the pipeline to reduce the potential of undetected leaks, which in the past have caused life-threatening fires and explosions. Hovering at low altitudes over the pipeline with special cameras and sensors, operators can send information to the assessor showing the pipeline's condition. Offshore oil platform inspections put workers at a higher risk. Lengthy shutdown damages efficiency and operations are forced to go offline. Using drones can help minimize these complications. Drones send real-time information to the operator at the rig while flying within meters of the offshore platform. High-definition video and still imagery can be provided from all angles. That is, vital information that can be used to access and plan necessary work in advance. Using drones for this application makes gathering information in dangerous environments possible, and extreme weather conditions no longer have to be a barrier to carry out such inspections. Drones are ideally suited to help avoid the massive damage that can result from oil spills. With the use of the right sensors, drones can be used to measure and quantify oil spills with the ability to access where the oil is spreading, how quickly it is moving in the water, and the specific areas it has reached. This real-time information can determine where to send response vessels and recover time previously spent on the process of damage detection. The highly sensitive optical sensors that are available with drones can help monitor gas emissions over critical sites and large areas that are otherwise difficult to cover. Let me give you an instance. Once the drone detects an oil spill area, the drone will analyze its behavior based on whether it is located in the marine spot, the spread diameter, the nature, etc. It will use the context to give details of the time of occurrence, the GPS coordinates, the exact location, and any other relevant data that will help the authority to decide on the course of action. With conventional technologies, it is difficult and expensive to determine what a vessel is burning while she is on the way. A drone with emission sensors on board can overcome that because the drone has a programmed data chaining system which greatly influences the stability, reliability, and accuracy and instantaneity of information it transmits. Vessels with large container ship has a speed of 28 knots. Unfortunately, most of the patrol craft in marine system cannot reach this level. So it is difficult to grasp the overall situation and to carry out a continuous and effective tracing. Drone can effectively supplement the shortage of the patrol craft in speed and efficiency. Drone can get to the scene immediately and fly above the object area with slow speed for the authority to examine the situation. With this advantage, the drones can reach the dangerous area that most people and craft cannot get in. It can improve the successful rate of monitoring, like the case of oil spilling and discharge of offshore transportation and marine petroleum exploitation. It is important to real-timely monitor the oil spill. The first few minutes detecting of occurrences. So, deployment of drones with airborne multispectral imaging radar to monitor the import routings and petroleum exploitation areas can detect the sea surface even at night. It will detect the temperature and color values of the discharges. The buoy is the main method to ensure safety navigation on the sea. There are lots of important lighthouse, light beacons locating isolated islands along the coastal areas. It is difficult to maintenance for the too much points, long lines, scatters, traffic inconveniences, etc. So with drones, the buoy can be quick patrolled and examined and be reported the state of buoys timely and effectively avoiding the aimless patrol. Knowing that crude oil is highly volatile, it is necessary to take countermeasures for vaporized gas. In such an accident, with drone surveillance, the monitoring team can see it earlier enough and will profile countermeasures before patrol spread coverage. In the past, workers would have to put their life on the line trying to locate damages and detect leaks onshore and offshore. Using technologies make it easier and risk-free. Advantages of using drone technologies over humans is that drones can provide real-time data by offering a wider scope of information to the authority. This technology hugely reduces the human resource cost in addition to providing valuable data and alerts, which can lead to indirect cost savings and improved efficiency and high risk aversion. Drones will be programmed with intelligence data to decide where to go. The data will include the protected marine areas, the pollution hotspots, the weather, so that automatically it can distinguish each context. Contexts include direct discharge, land runoffs,